All right, so today is Friday, September 21st, and what we're doing. We're working on classification matter. We're working on formula weight and molar mass today. That's going to be in the lecture. And then you're going to do a POGL, which is a group activity on classification of matter. Again, we're not going to rotate today. We're just going to stay where we are, but that doesn't mean you work alone. You work with a partner, at least, or your group of 4. Your daily work is going to be your notes for today. So once you're done with your notes and the practice that's in there, make sure you upload it. The POGL does need to be uploaded when it's done. So you got 2 things to upload today. If you haven't uploaded the stuff from yesterday, make sure that you do. It's just that one page for 2.2, daily work 2.2, and then your Serialum lab. A lot of you have not uploaded the Serialum lab, so make sure that you do that. I put the periodic table song here again for you, so you can annoy yourself with it if you'd like. All right, so here we go with the lecture for today. So again, today we're going to worry about classification of matter, how to classify different pieces of matter, and the molar mass or formula weight. So this is a really bad picture. I'm sorry, it didn't copy real well. On your paper, there's also the same thing. This is how we classify matter. So matter overall is everything. Okay? From there, we can go down to pure substances on the left or mixtures on the right. So what we're going to talk about is mixtures first. Mixtures are just when I put 2 or more things together, and I can physically separate it. So like if I had sand and iron together and with a little salt, how could I separate that mixture? If I had sand, salt, and iron together. Anybody give me an idea? How can I physically separate, not change the quality of any of them? Yes?
Like a filter.
So filter, he's thinking, you need to do something first before you can filter, but that is one of the steps. Yes? A magnet. What would the magnet pull out? The iron. So I get a magnet, I pull out all the iron. Now I've got sand and salt left. How do I separate it? I don't want to change sand and salt, I just want them separated. Okay, what do I need to do before I use the filter? Because that was the same thing he did. Because if I put them in a filter, the sand and salt are going to stay there. Yes?
Add water.
Add water. What happens when you add water? The salt dissolves. So if I put sand and salt in a filter and then I add water to it, the salt's going to go through with the water because it's going to dissolve, but the sand won't dissolve, right? So it'll stay in the filter. Then what do I do to get the salt back now that it's dissolved in the water? Evaporate the water. So then that is a physical means. So if I can separate something by physical means, it's a mixture. If it's the same throughout, okay, if it's the same throughout, then we call it homogeneous. If it's different throughout, like a chocolate chip cookie, I could sit there and mine all the chocolate chips out, and they could be separated. But they're not equally in that cookie. Does that make sense? I can take a bite and sometimes get 4 chocolate chips, and other times only get 1. That's heterogeneous. That means it's different throughout, okay? Over here on pure substances, we're talking about what's on the periodic table as an element, okay, as an element, and most of them just hang around by themselves. But up here, bronhifcal, bromine, oxygen, nitrogen, hydrogen, iodine, fluorine, and chlorine, they hang around in pairs. They're like twins. They're Siamese twins connected at the hip, and they go around everywhere together. And then there's our 2 special elements on the periodic table, P and S. PS, by the way, they're special. Phosphorus hangs around in 4s. Sulfur hangs around in 8s. So they're like the multiple birth thing. They're very, very rare, but special. Okay, so that's elements. If it's just one atom that goes around by itself, like iron or like aluminum, it's called an atom. If it's 2 or more, it's called a molecule. But they both are elements. Everybody okay with that? On the other side here, we've got compounds. Compounds can also be molecular, meaning I have things that hang together and they're different elements and they share. So molecular is like sharing. So on the periodic table, they're close together. So that's like carbon dioxide. Look at where carbon and oxygen are. They're close together on the periodic table. Those are molecular, okay? That's because they're sharing bonds. Neither one of them is strong enough to rip the electron off from the other one. Okay, so they have to share. The other kind of compound is when they're farther apart on the periodic table, like NaCl. You see that's far apart on the periodic table from your periodic table? That is called ionic. One is stronger than the other, So one will give up the electron to the other, and so they're charged. And because they're charged, they hang together. Okay? Because opposites attract, right? Okay, so that's how that works. Everybody okay with this? We're going to go forward. All right, so we need to define element, compound, mixture, homogeneous, and heterogeneous again. Element. What is on the periodic table? That is an element. Okay? A compound. Two or more elements together. Two or more elements together. Okay, now just remember in your mind, when they say atom, that means element. When they say molecule, that means two or more things together. Okay, for both element and compound. But for compound, it means they're close together. Okay. If they say ionic for a compound, they're far apart on the periodic table. On mixtures, homogeneous. Whoops. You guys need to get that down. Are you guys okay? Okay. For a mixture, it's something that's put together, but then I can separate it physically. So T is a mixture because it's mixed together and it has really no overall formula. Okay? It has lots of different chemicals in it. Homogeneous means it's the same throughout. So it's a mix of all these different chemicals, but it's the same throughout. So homogenized milk is the same throughout. If they don't homogenize it, it separates into cream, light milk, and even lighter milk. Heterogeneous is different throughout. So it's a bunch of chemicals, but the whole solution is different throughout. That would be like, a homogeneous would be like mayonnaise. Heterogeneous would be like a bowl of fruit. It's different throughout. Okay? Then, when we get to molar mass or formula weight, we look up on the periodic table. So we did a lab last time, it was candium, and we mixed all these cereals, and we figured out what the overall mass of sorry, not candium, we did cerealum this year, what cerealum was. And we were able to say, okay, that's the molar mass of that element cerium. So to get the molar mass of an element, we just look on the periodic table, and you should have your periodic table in front of you, right? Because I asked you to get it out. Would you look up really quick and put the formula mass of each of these down? To give you a head start, I'll do calcium for you. Whoops, I will not do calcium for you. I will do it. It is 40.078, and remember that parenthesis is most of the scientists agree on it, and some of them don't. So they put that last one in the parenthesis. That's all the parenthesis means. You still can use that number. You don't have to put it in your calculator like that. You would put it in your calculator like this. Okay? That parenthesis just means not all scientists agree on that last number. So really quickly find yttrium, mercury, silver, osmium, and tellurium. I'll give you a hint. Yttrium is in the sunken part on the left-hand side. Just write this kind down. So you sort of ignore the parentheses. Just write the number down, the parentheses, just to tell you not all scientists agree. Okay? Hg is mercury. It's on the right-hand side of the sunken area, partway down. Osmium is in the middle of the sunken area, partway down, and tellurium, it is in the far right area, and Hg is in the middle sunken area on the right, and so is silver. Ag is silver. Okay, the hardest part about this, you probably are realizing right now, is just finding the element. Okay, I am not one of these teachers that has you memorize the periodic table. There are some that will have you memorize it, but what I've found is after we use the periodic table for a while, you just know where they are. Okay, so and that's what you need to do, is know where they are. So go ahead and have that periodic table out because we're going to be using it a lot. I'm not going to write these down because you can get them right off the periodic table, right? Everybody okay? Just to double check, what was silver? 107, good. So you're writing that down right from the periodic table. That's awesome. Now, when we get compounds, Compounds have more than one element, right? So as I have this compound, Fe2O3, the 2 tells me how many ions I have. The 3 tells me how many oxygens I have. So to write its, what I do is I go Fe, I have 2 times, I look up on the periodic table, find Fe. It's on the middle of the sunken area, 55.845. Everybody found that? Okay. And how many oxygens do I have? Well, I have 3. That tells me how many. And oxygen's on the top of the right, and it's 15.999. I'm going to add those together. And I like to write it this way. If you want to write it out in a straight line, you can. I'm just the old-fashioned elementary, line them up kind of thing. Just helps me to see what's going on. And when I have a lot of things, I make sure I got every single one element that I need. Okay? So somebody grab your calculator. Actually, everybody grab your calculator. Go ahead and punch it through, and let's see if we all get the same number. So 2 times 55.845 plus 3 times 15.999. If you don't have a calculator, grab one of mine. You're going to need one today. I want to see if everybody punches it through the same way. Gets the same thing. So we can fix any problems there might be. Okay, who's a brave child, wants to share? Yes.
You want me to show what I got
For the whole thing.
159.687.
Okay, thumbs up, I got that same one. Thumbs down, I didn't. Thumbs sideways, I have no idea what I'm doing. Okay, thumbs up, that's awesome. Now, we can use a whole number if we need to, but usually we report it to 5 significant figures. So I would report this as 159.69 grams is equal to 1 mole of Fe2O3. Okay, and oftentimes we'll write the Fe2O3 over here. In fact, I should have. So when you do your practice right here, and I gave you some real easy ones, you're going to write at the end how many grams of whatever is equal to 1 mole of whatever. Okay? These are our equilibriums I told you about that we had started doing the dimensional analysis. Remember that? With things we knew. Now we're going to be starting to do it with things we don't know. Yes?
When you transferred the 159, did you mean 0.68 instead of 0.69?
Okay, so good question. Right here is where the 5 would go. Since this is bigger than 5, I round up. Okay, so I'm not truncating. I'm looking at the next thing. Okay, so these would be your practice. Let's keep going forward. You can do your practice in a minute. Here's a little bit harder one. Ooh, this one has parentheses. So I need to be really careful how I do this because the number outside the parentheses times this through to each of those. Okay, so if there was a number inside the parentheses, I would have to times that by the number inside the parentheses. Okay, so like this one on your practice, I would have to go 3 times 4 to get how many hydrogens. Okay, so on this one up here, we would go strontium. There's just one of them, so I look on the periodic table and I look for strontium, and it's 87.62. It's on the left-hand side of the periodic table. Then I look for nitrogen. How many nitrogens do I have, guys? 3. Good. So I'm going to go 3 times nitrogen's mass. Nitrogen's on the right-hand side of the periodic table, 14.007. And then I've got oxygen. How many oxygens do I have? 3. And oxygen, you're going to have memorized really fast because we use it a lot, 15.999. We're going to add that up. Quickly add that up, and let's see what you get for our molar mass for this is strontium nitrate. Okay, another person that hasn't helped me before, being brave. Somebody got it done? Did you give it to me?
177.218.
Okay, thumbs up, that's what I got. Thumbs down, that's not what I got. Oh, no, punched it in wrong. It's okay. What did somebody else get? Let's erase that. Okay, thumbs up, I got that one. Thumbs down, I did not. Okay, thumbs up. So you were off just a little bit, so it's okay. It's always good when you're doing this in practice, especially that you check with your neighbor, did they get the same thing you did? Because oftentimes just one slip of the finger there can mess it up, and that messes the whole problem up. So I always add it twice. Just, I'm one weird person that way. So I write down what I got the first time, I add it one more time, double check myself. Okay? So this we would round to, because again we want to go to 5, so we're looking here, we're going to round up. 177.64 grams of strontium nitrate equals, whoops, I put the 3 in the wrong place. Ha, ha, ha. I know why I did that. This formula is written wrong, so it's okay. We'll just pretend this is not strontium nitrate, but that's all right. Is equal to 1 mole strontium nitrate. But you guys wouldn't know that yet, so I guess we're okay. Okay? I'm going to have to point that one out. Okay, so you get to do one on your own. So I've done one with you with a more complex formula. You'll do one on your own. Just remember that 3 is going to come through in times here, and it's going to come through in times here. When a number's not written, it's a 1. Okay, so we don't write 1s as subscripts. I'm going to keep going. You got more practice, a couple more after that. Okay, so we're not going to do stations today, but we are going to do a POGL. Which is just a group activity. So 2 main things you're learning today, how to write, how to figure out molar masses, and then you're going to be working on how to separate matter into its element, compound, mixture, and what kind of mixture it is. So I'm going to pass these out. You're going to work with your partner next to you. So if you don't have a partner, make sure you're moving so you have somebody next to you so you can work. It says at one point, cut it out. Don't cut it out. I crossed through it, but my writing with a computer pen with the mouse is not real great. So when I crossed it out, it says, don't cut it out. That's what it's supposed to say. Okay? So are there questions on what needs to be done today? Because basically the rest of the time is for you to finish your practice. Remember that I've got the iPads up here that you're welcome to use and upload your daily work or your POGL with. If you're having problems with yours, or if I've said, you know what, you're really fuzzy, please focus, and you keep getting that, it's fuzzy, please focus, please use my iPads so that I can get a clearer picture for you. Okay? Any questions? All right, I'll pass this around, and you're good to go.